Hello and welcome. In this video we are going to play a bit around with machine learning on intraday cryptocurrency data. In specific, we are setting up a random forest classifier to predict the movement direction of a certain coin based on a set of technical indicators. So our dependent variable, y, would be the direction of the movement over the next n time steps. As an example, we would get a 1 if the coin was climbing over the next, let's say, 1 hour, and we are getting a 0 if it was dropping over that time horizon. The independent variables are just a set of technical indicators. Please take a look at the video description for references, further readings, and conceptual explanations. Some notes. First of all, the video is at least mostly not containing conceptual explanations. Secondly, there are some simplifying assumptions which have to be taken care of. For instance, I'm just taking a look at the movement itself and not that the movement is big enough to cover, e.g., transaction costs. In general, this video is supposed to be a preparation to integrate some machine learning into potential trading bots. So if you're interested in that, please let me know. Important disclaimer, all concepts shown in this video are not an investment advice. Okay, so let's get started. As you see, we need some libraries, pandas for data handling, TA to calculate technical indicators. We need the Python Binance library to pull prices from Binance. We need NumPy for conditional checkings, and here I'm just instantiating the client to be able to pull prices from Binance. Next, I want to pull intraday price data, and I'm doing that with a function which I've already covered in some of my previous videos, so I will just copy paste that from my other screen, but I will go through that with you together. So this function getData is pulling price data for a given symbol, let's say Bitcoin USDT. And it's pulling K-line data for that symbol for a given interval. So in this case, I just took 15 minutes, but you can take 30 minutes, you can take 1 hour, you can take 1 day, whatever you want. And this is just the look back period. So here in this case, I'm just going back 1K hours. You can go back 2K hours, whatever you're interested in to examine here. This is just slicing unnecessary data away, and then is renaming the columns to what they actually are. So time, open, high, low, close, and volume. Then I'm just setting the index of that data frame to the time column, and I'm just formatting the currently Unix formatted time index into a human readable time index. In the end, I'm just formatting typecasting the currently string formatted values into floating values. So let me just show you how this data will look like for, let's say, Bitcoin USDT. You will just end up with a data frame containing open, high, low, close, and volume data on the 15-minute interval here. And we're actually getting 5K rows here. All right. So let's store that in a variable df for data frame. And then we can proceed to calculate some technical indicators. I'm just taking some examples here so you can check out whatever technical indicators you are interested in. I'm using a function to do that. So I'm just calling that apply technicals. And I'm starting with a loop where I'm just calculating, e.g. the RSI for 2 days, 4 days, 6 days, 8 days, and 10 days. And also the SMA for 20 days, 40 days, 60 days, and so on, just to have more than one SMA, more than one RSI, and so on, right? So it's just an idea, just so you can check out, as said, whatever you're interested in. So I'm looping for in range 2 to 10 with a step of 2, and then I just want to have an RSI column for every iteration here. So I'm just taking RSI underscore plus the I here and use TA momentum RSI on the close column and provide my window as I, right? So you will see in some seconds what exactly will happen if you will execute that. So in a nutshell, you are just getting RSI2 is the RSI2 on the 2 day window, or not 2 day, in this case, 2 15-minute window, 4 window, 6 window, 8 window, and so on. Same for SMA, so simple moving average But here I'm doing it a bit different. I'm multiplying it by 10 just simply because I don't want to have the SMA over 2 days or 2 time steps, but rather 20 days here, 40 days, 60 days, 80 days, and so on. So I just multiply that with 10. So I need the SMA formula, which is simply rolling over the close column with a rolling window of I times 10 again and taking the mean here. So also taking a look at the MACD here, using TA trend, MACD difference on the close. And that's it for the technical indicators. As said, way more possibilities. It's just an example. In the end, I'm dropping N values, which are occurring, e.g. over because of rolling windows here. So if I apply that on my data frame, so let me show you once again how the data frame is looking like. Open, high, low, close volume here, right? 15 minutes time steps or intervals. So if I'm applying that on my data frame will look like this. So you see RSI 2 here, column containing the RSI on a 2 time step window, SMA 20, the simple moving average over 20 time steps, RSI 4, and so on, right? In the end, I have the MACD difference column as well. Okay, so technical indicators calculated. Now let's move on defining our independent variables and our dependent variable. I'm doing that within a function. I'm just calling that xy. This is taking our data frame and also a period. And this is just the period you want to consider. So if you want to have the movement over the next 15 minutes, you are taking a period of 1. If you want to have the next 15 minutes, so the next 30 minutes, you're taking a period of 2, and so on. And now our y is, as said, just the direction of the movement. So first of all, we have to determine the movement itself. And let me just show you how this is working outside this function. So we are taking the close column, shift that by -1, and then subtract the close column from that. And we're ending up with a series like this. And let me show you the close series. So this is just the difference between this row and this row. All right. So we want to have that in this row actually, so that we can take the x values to predict the next day. So this is the movement, or not next day, sorry, on the next time step. And this is the movement on the next time step, right? So this here in this row is the movement in the next time step, but I'm shifting it by -1 so I have it in the same row here. So it's nothing more than that minus that one, and it is 111.10. All right. Now this is just the price change here in absolute terms. So I wanna use NumPy and just check if that value is positive. I wanna have a 1, and if that value is negative, I wanna have a 0, as explained in the beginning. Right? So let's formulate that in the function. But one more thing for the independent variables, I'm just taking all columns here. So even the open, high, low, close, and volume column I'm integrating here. Okay, so first of all, our y is df close shift by minus period minus df close. And then I have to cut off the period here, because if I'm showing you, if I'm shifting that by -1 here, I will have an NaN value in the very last row. And the same is also for the x value. So I have to cut off the last row. So I just have to cut off the provided period on both the x and y variable here. So I'm taking y equals y until the period, and also for the x values. So I'm just taking the data frame and go until the provided period. And finally, I'm just determining numpy where, and then where my y value is larger than 0, I want to have 1 and else 0. In the end, I want to have my x and y values. So let's take a look at how this is looking like. If we provide our data frame and a period of 1 here, I would have my x as my data frame and my y as an array of a binary values here, right? So 1 and 0. So 1 if the asset was rising, and 0 if the asset was dropping here. Okay, and now we have everything what we need to provide that to our random forest classifier. But before that, we have to split the data set. If we would just feed this into our random forest classifier, we would get very, very good accuracy values here, but this would just be overfitting, so we have to split the data set into a training and testing data set. So therefore, we need to import from sklearn the train test split. It's very convenient to split your data set into a train and test data set, and then we are just defining x train, x test, y train, y tests, and use train test split on x and y. Take or set the test size to 30%. It's a common value for the test size. Define a random state, so just that we can replicate this randomized train test split. And in the end, very important, because we are working with time series data, we have to set the shuffle to false, so that we are getting a split and not shuffle the data, because we are working with time series data, and we just want to give me the data until a certain amount of time, and then take the rest of the data as the test data. And this is why I'm saying the shuffle to false. But I'm showing you how this is looking like. So the X train data is going until 11th of April here, and the test data is just going from 11th of April until now. All right. So this is the split when we are not shuffling the data. Right, okay, so we have everything what we need to feed our random forest classifier, but before that we have to import it from sklearn ensemble import random forest classifier. Define the classifier as random forest classifier, and again provide random state to make it replicable, and now fit it on our training data. So provide x train and y train, and then you're getting some information, e.g. that the Gini impurity was used here, and now we can make our predictions. We are just storing that in a variable pred and use clf predict, and then on the test data. With that, we are getting our predicted values in an array. So 0 for a downward move and 1 for an upward move. And we can compare those predicted values now with the actual values. Therefore, we could use a confusion matrix, which we can import from sklearn metrics, and take a look at the actual values and the predicted values, ending up with a confusion matrix like this. So just as a reminder, in sklearn the confusion matrix has another structure than e.g. a confusion matrix, which you know from the textbooks. So this is not the true positive value, but this is the true positive value. All right, and this is the true negative value. So what is this value telling me? This is telling me that 383 predictions on an upward move were actual upward moves. And this value is telling me 226 predictions on a downward move were actual downward moves. And these two values are just the values which were predicted wrongly. So just as a side note, you could take a closer look at so I'm just calling that true negative, false positive, false negative, and true positive here, and extract them from the confusion matrix using reval here. With that, you are getting all values, so the true positive, as you see here, and the true negative, as you see here, and so on if you're interested in that. Because I personally find it somehow, literally confusing. Take a look at the confusion matrix like that, because I always think on the left upper corner is the true positive values. But anyhow, let's take a look at the accuracy, which is just the share of correct predictions in relation to all data points here. So these are basically just this value plus this value divided by the sum of the whole array here. So we can just import that from SQL and don't have to do that by hand here. So yeah, let's just import it here. Accuracy score, and let's also take a look at the precision score. Could be interesting in this coherence here. So first of all, let's take a look at the accuracy. So the share of right predictions, providing the true values and the predicted values. And now we are getting 52 roughly %, which might be disappointing, but is at least better than random guessing. Also interesting could be to take a look at the precision. That is the share of true positives on the overall predicted positives. Could be quite interesting, e.g. if you're only interested in entering the trades and find the exit for yourself. So let's take a look at that. But as you see, not that much of a difference. Let's finally just take a look at another coin here. But you can play around with that for yourself. Right, so I'm just executing all cells again. And for ETH, you see we have a slightly higher accuracy and a higher precision, right? Yeah, so play a bit around with that. Take a look at other intervals, at different coins. And yeah, thank you very much for watching. I hope this was interesting, helpful, and informative. So I'm looking forward to seeing the upcoming videos. Bye bye.